Welcome to the deep dive. Today we're taking a really necessary and detailed look into one of the most contentious topics in modern medicine. The safety record, the regulatory history, and, the whole persistent debate around silicone breast implants.
And this is more than just a summary. Our mission today is really to pull apart the central conflict in this decades-long story. We're going to be piecing together material that, well, it gives you a view behind the curtain.
Okay, so what kind of material are we talking about?
We're talking internal corporate documents, cross-examination testimony from the big scientific panels, and the really rigorous standards of modern regulation.
And it's crucial, we mentioned this up front, the documents guiding this deep dive, all the internal memos, the deposition transcripts, the panel reviews, they've been carefully researched and provided for our analysis by SVS Meldpunt Klachten Siliconen.
Right. And that gives us a truly unfiltered look into what the manufacturers knew, the specific chemical makeup of these devices, and, frankly, the integrity of the studies that shape the whole global safety consensus.
So what's the core tension here? What's the main question we're trying to answer?
The core tension is this fundamental disconnect. I mean, how do you have known toxicity signals from key components, admissions of material literally migrating through the body, and huge methodological flaws in the key studies?
Right.
How does all that align with the current regulatory classification of these devices as safe? Especially when we focus on the documentation of industry money and the behavior of chemicals like D4 and this thing called amorphous silica.
Okay, let's unpack this. It's a dense history. I think we have to start at the beginning, right?
Yeah.
Inside the corporate walls of the manufacturer, specifically Dow Corning.
Exactly. We have to look at the documents that came out during the big liability lawsuits. This material shows that the early concerns weren't just, theoretical worries. They were documented internal realities.
And they date back decades. So, Section 1, the corporate knowledge pipeline. What did they know and when did they know it?
The internal documents, they confirm that manufacturers were seeing significant material issues surprisingly early. I mean, it really got to a critical point by the mid-1970s.
The 70s?
The mid-70s. We have communications from 1976 where Dow Corning staff were already grappling with what they themselves called the disturbing phenomenon of gel migration.
Disturbing.
Yeah.
That's a powerful word to find in a corporate memo. It suggests a lot more than just a minor expected leak.
Oh, it was far more. What was so disturbing was the scale of it, the sheer distance of the migration.
So what happened?
There was a man, Art Rathjen, a senior clinical research specialist for Dow Corning. He wrote a letter in 1976 admitting he was, and I'm quoting here, caught off guard by a report.
Caught off guard by what?
By a report detailing gel migration.
Yeah.
And the specific case they cited, the one that really shocked him, was that the silicone gel had migrated all the way to the groin.
Wait, from the breast down to the groin.
Yeah.
That implies it's not just a local issue. That's systemic movement through the body. That's a massive red flag.
It's a huge red flag. It points to a total failure of the shell to contain the gel. See, when the gel gets out, the body tries to wall it off, but that often fails. And then the low molecular weight components can just travel.
The lymphatic system.
Either that or just through tissue planes over time.
Yeah.
The company knew this was a possibility, but I think this report just showed them the alarming extent of it.
And this was all happening in a really dire context, wasn't it? Because in that same year, 1976, we have a Dr. Charles Vinnick writing about the tissue reaction around a ruptured implant.
Yes, this is a critical connection. He looked at the tissue under a microscope and noted that the reaction, it appeared to resemble the reaction seen around silicone-injected breasts.
So he's directly linking a ruptured implant to liquid silicone injection.
He is. And you have to understand, direct liquid silicone injections were already infamous by then. They were known to cause these severe, chronic, devastating inflammatory reactions.
So by drawing that parallel, Vinnick was essentially saying that the material from their product, once it was out of the shell, was causing the same kind of damage as a practice already known to be incredibly dangerous.
Precisely. The experts knew. They knew in 1976 that the components were causing these tissue reactions.
And yet, this didn't really change anything, did it? Not for a long, long time. Which, I mean, it immediately makes you question the integrity of all the data that came later.
It has to. And that brings us directly to the epidemiological studies, the ones the National Science Panel relied on. Because if you do a meta-analysis, you're pooling results from other studies.
Right, you're averaging them out, in a sense.
But if those original studies are compromised by bias or bad methodology or financial influence, then your whole consensus is built on sand. And this is where the documentation on the money trail becomes absolutely essential.
Okay, so let's get into that, the financial influence on these key studies. We should probably focus on the deposition of Dr. Barbara Holka, right? She was one of the lead epidemiologists on that national science panel.
She was. And her job was to review all the existing science, published studies, and some that weren't.
And that's where this Teal dissertation comes in.
Yes, a key example. It was an unpublished PhD study. Dr. Holka testified that she personally looked into Teal's work, decided it was methodologically sound, and so she included it in her big meta-analysis.
But when she was asked about the funding for that study,
Her response was stark. She testified, and this is a direct quote, "I did not know who funded this study."
so let me get this straight. A major piece of evidence used to build a national safety consensus was an unpublished academic paper, and the senior epidemiologist validating it had no idea who paid for it.
That's right. And it turns out the funding was traced directly back to Dow Corning.
Wow.
So the manufacturer was funding a study that's then used to determine the safety of its own product, and the lead reviewer is kept in the dark about that conflict of interest.
And it gets worse, right? She didn't have access to the letters between the researcher and the company.
Correct. Dr. Holka also testified she never saw the correspondence between Teal and Dow Corning. So she had no way of knowing if the company had influenced the study's design or how they interpreted the results.
It's just astounding. I mean, relying on an unpublished paper is already a bit of a weakness, but for the funder to be the defendant in the case, it just negates the credibility, doesn't it?
It completely undermines it. And this wasn't a one-off. This pattern of financial linkage was, it was pervasive. You see the same dynamic in some key Scandinavian papers that were cited all the time, the Nyren and Winter papers.
And how did that work?
These studies shared a co-author, a man named Joseph K. McLaughlin, who was with the International Epidemiology Institute. And if you look at the disclosures, you can see how the corporate money was channeled indirectly.
Okay, so let's look at the Nyren paper on connective tissue disease. What did the disclosure say?
It said the funding came from the International Epidemiology Institute, but then, in the fine print, it follows up by stating that the institute, in turn, received funds from the Dow Corning Corporation.
So that's the mechanism. Indirect funding. You pass the money through an intermediary, and it softens the direct link between the manufacturer and the study.
It obscures it. So you have a study looking at autoimmune diseases in women with implants, and it's being paid for indirectly by the very company that would be liable.
And it wasn't just Dow Corning?
No. The other Nyren paper, the one on neurological disease,
Yeah.
and the Winder paper, they listed funding from 3M, Minnesota Mining and Manufacturing, another major implant manufacturer.
It shows a coordinated effort to fund the literature base.
And the problem goes beyond just the studies. It even touched the expert panelists themselves. Take Dr. Peter Tugwell, the rheumatologist on the panel.
He specialized in the very diseases they were studying.
Exactly. And he was involved with something called the OMERACT conferences, which are all about rheumatoid arthritis. He initially disclosed that 3M had given a $5,000 contribution to these conferences.
But there was more.
During his deposition, he had to admit there was an additional undisclosed contribution. He testified that he later remembered a contribution from Bristol Myers Squibb, another defendant in the lawsuits, that he hadn't listed on his original conflict of interest form.
I have to stop you there. This is just a critical point.
Yeah.
The experts who are supposed to be objectively synthesizing the literature are being financially supported by the defendants, not just for the studies, but for the conferences that define the standards for the diseases themselves.
Yes.
What does that tell us about the scientific independence of this whole consensus?
It tells us that while the panel reached a conclusion of low risk by adding up all the data, the foundation the data was built on was profoundly shaky. Dr. Holka herself admitted she could find something she disliked in almost every article.
Right.
So you take those inherent scientific weaknesses, and then you layer these documented financial conflicts on top.
Yeah.
And the entire consensus just loses a huge amount of weight.
Okay, if the financial toxicology makes the data unreliable, let's pivot to the chemical toxicology. We've established they knew the gel migrated. So now, what exactly was migrating? Let's talk about things like D4 and amorphous silica.
The material science of the early Dow Corning implants is key here, the Cronin design. The shells were made from a heat-cured elastomer, but they used amorphous silica as a filler.
To make it stronger.
To give it structure, yeah. And they use a process 8, 2,4-dichlorobenzoyl peroxide, during the curing.
And the manufacturing process was supposed to clean all that up, right? They had a final oven baking stage to get rid of the volatile stuff.
It was supposed to. But internal communications showed that even after baking, A residue of 2-4-dichlorobenzoic acid, a potentially toxic component, still remained in the final product.
At what level?
20 parts per million, which, it might sound small, but this is a contaminant in a device designed to stay in a human body for decades.
But beyond that residue, the real long-term concern is the gel itself. The low molecular weight siloxanes, specifically D4.
D4 is a critical substance here, octamethyl cyclotetrasiloxane. It's a cyclical siloxane, it's highly volatile, and it's inherently migratory. It's not permanently locked into the gel.
So it bleeds out.
It bleeds. It seeps from the implant into the tissue and eventually into your systemic circulation. And it's a slow, continuous, ongoing process for the entire life of the device.
What did the toxicology data, the IOM reviewed, say about D4?
The IOM report was, let's say, nuanced. It cited studies showing that if you breathed in D4, it didn't seem to cause acute immune effects in humans.
Okay.
But when researchers looked at skin and oral exposure studies in animals using related organopoly siloxanes, the findings were much, much more severe.
What kind of severe effects are we talking about?
We're talking about really adverse effects on the reproductive systems of rats, rabbits, and dogs. The documents cite testicular atrophy in male rabbits after only 28 days of having this stuff put on their skin.
28 days.
And for females, they saw maternal weight loss, increased fetal resorption, which is basically miscarriage, and decreased viability of the young.
And even though the IOM noted these specific compounds weren't proven to be in the implants, D4 is, and it's structurally related to them.
That's the point. The chemical family exhibits severe reproductive toxicity in animals. That should have been a screaming siren about the long-term risk for humans. It shows that silicone is not inert when it breaks down.
Which it does.
Absolutely. Degradation studies confirmed a slow, ongoing breakdown. So the body isn't just getting one dose, it's getting this decades-long, low-level chemical infusion.
And that continuous infusion brings us to the second critical component, amorphous silica. This wasn't just a trace contaminant, it was deliberately added to the shells.
That's right, as a filler. And the toxicity of silica, especially in fine particle form, is not new information. It's not modern knowledge.
How do we know that?
Because the IOM's own reference list, buried in its toxicology section, includes materials that confirm this.
Right.
We see a reference to a paper by Policard and Collette from 1955.
1955.
Almost half a century before the IOM report. And that paper was titled Toxic and Fibrosing Action of Submicroscopic Particles of Amorphous Silica.
So the IOM panel referenced a paper from 1955 that literally describes this filler material as toxic and fibrosing, meaning it causes scar tissue.
Yes. The knowledge was there. It was available in the scientific literature for decades.
And this matters so much today because we know that this amorphous silica is what we now call nanoparticles, right? It's fumed or pyrolytic silica.
Exactly. Submicroscopic particles. When the shell degrades or ruptures, these nanoparticles are just released into the tissue. And a 2012 study by Zhang looked specifically at these particles and confirmed what researchers suspected decades ago.
And what did that modern study find?
It showed direct cytotoxicity. It damaged human cells in a lab setting. And even more dramatically, high doses caused hemolysis.
What's that?
The destruction of red blood cells. The study linked these effects directly to oxidative stress. In simple terms, these tiny silica particles, a known component of the implant shell, actively damage human cells by inducing chemical stress.
So you have a component deliberately put in the device, known since 1955 to cause fibrosing, and modern science confirms it kills cells. And we know it gets released.
Yes. And the IOM bibliography even lists fumed silica, trimethylsilly, treated as an established component. So this isn't some abstract theory. It's a known structural material with known toxicity risks.
Which creates this huge paradox, doesn't it? Because despite knowing about the migration of toxic agents like D4 and the reactive nature of silicon nanoparticles, the official conclusion from the IOM was that there's no evidence it causes enough local inflammation to trigger a systemic disease.
Right. They couldn't find the link to classic autoimmune diseases in the big population studies.
But if these chemicals are migrating and they're cytotoxic,
right,
the body has to be reacting to them. So where does that reaction show up, if not systemically?
It shows up locally. Around the implant capsule, this is key. Dr. Diamond, who was on the immunology review, testified to this. He said that while the evidence for systemic diseases like lupus was unsupported, the local symptoms that women reported, the pain, the redness, the hardness, the fatigue around the implant site, those are likely due to local inflammation.
So this confirms the lived experience of thousands of women.
Exactly.
The body recognizes these components, the silica, the D4, and it tries to wall them off. But that walling off process is itself inflammatory and painful, and it persists because the materials keep degrading and migrating.
It's the perfect explanation for the local distress so many women report, even if it doesn't meet the strict criteria for a systemic disease in a large study. The materials are simply not inert. They are chemically active.
Okay, that forms the perfect bridge to Section 3. Why did the epidemiological consensus struggle so hard to find a systemic link, despite all this chemical evidence? Let's turn to the formal conclusion from the National Science Panel and the IOM.
The conclusion, which was delivered by the panel with Dr. Holka and Dr. Tugwell, was pretty unambiguous. They found no reliable and reasonable scientific basis to conclude that silicone breast implants cause or exacerbate classic connective tissue diseases or atypical diseases or any related symptoms.
And Dr. Holka herself confirmed she believed an association is unlikely to exist for things like Sjogren's syndrome or lupus.
And Dr. Tugwell gave this statistical reason why. He pointed out that across all the studies they reviewed, no risk estimate has a lower confidence interval greater than 1.
Okay, let's break that down. That's a key statistical phrase. What does a confidence interval overlapping 1 actually mean in real terms?
It means that statistically, you can't rule out that the risk is 0. Or even that the implants are protective, though that's unlikely. A risk ratio of 1.0 means no difference in risk between the implanted group and the non-implanted group.
So if the range of possibility, the confidence interval, includes the number 1,
then the result isn't statistically significant. You can't claim there's an increased risk. And that's what they found, study after study. No single study showed a statistically significant increased risk of these classic diseases.
that is the consensus, and it's a powerful one. But to really understand it, we have to dig into the methodological limitations, the caveats, the things the epidemiologists themselves admitted under oath.
This is where the story gets really complicated. And the first major issue, acknowledged by Dr. Holka, was the latency period.
Meaning how long it takes for a disease to develop.
Exactly. She conceded that if there's a plausible latency of, say, 5 to 10 years for an autoimmune disease to show up after you're exposed, then a lot of the women who were implanted during the peak in the mid-'80s would be completely missed by the studies.
Because the studies had early cutoff dates, like the Mayo Clinic study.
The Mayo Clinic study is a perfect example. It followed women implanted up to December 1991. So you got your implants in 1990, and the study stopped looking at your records at the end of 1991.
You had a follow-up of 1 year, maybe?
At best. Dr. Holka confirmed under oath there were women in that study who were followed for 0 years.
0 years.
So if you're looking for a disease that takes 5 or 10 years to develop, and your study includes thousands of people with basically 0 follow-up, you're statistically blinding yourself to the outcome. It's a massive structural weakness.
It's like trying to time a marathon runner by only watching the first 100 yards.
Precisely. The second major limitation is case ascertainment bias. This was a big problem in studies that relied on large databases, like the Danish Edworthy study.
And what was the bias there?
That study only counted a case if the woman was hospitalized.
So if a woman had a definite serious case of rheumatoid arthritis, but it was all managed through outpatient clinic visits and prescriptions, she didn't count.
She did not count. She was invisible to the study. Dr. Holka acknowledged this directly. And the panel struggled to figure out how big of a problem this was. They asked, how many people with these diseases ever actually get hospitalized?
And did they have the data to answer that?
No. Dr. Holka admitted, I do not know the data on that subject. So they made a huge methodological choice without knowing the magnitude of the bias it introduced. It's a systematic undercounting of cases.
Which would naturally push the risk estimates down.
Of course. Then the third issue is specific disease power. This is about whether your study is big enough to find a risk for a very rare disease.
Like scleroderma or lupus.
Right. Dr. Holta confirmed you need very, very, very large studies to detect an association for these. But when they looked at scleroderma, the meta-analysis had almost no data from the best kind of study, a cohort study. They had to rely on weaker cross-sectional studies.
Which are just snapshots in time.
Exactly. Not great for figuring out cause and effect. And even for diseases like lupus, where they had some cohort data, they admitted they hadn't actually calculated the statistical power of those individual studies to see if they were even big enough to find an effect.
So the lack of an association might just be because the studies were too small to find one?
It could be. And that's very different from proving there's no risk. Finally, there's the whole problem of defining atypical disease. All the women with chronic fatigue, cognitive dysfunction, widespread pain.
The panel concluded they found no convincing evidence for that.
They did. And their rationale was that these symptoms are incredibly nonspecific. Lots of people in the general population have fatigue and brain fog.
So they said you couldn't study it without a clear, testable disease definition.
Which creates a catch-22, doesn't it?
Mm.
You can't do the study without a definition, but you can't get a definition without a study that proves the symptoms are a real syndrome.
They just decided it was impossible to do.
It was a methodological dead end for them.
Mm.
And it leaves thousands of women with very real symptoms that are just statistically unprovable within that framework.
So the net result is a consensus that's statistically low but just riddled with flaws. Let's pivot now from that elusive systemic risk to the physical reality of the devices, which the IOM itself flagged as the main problem.
Yes. This is where the Institute of Medicine review was crystal clear. They stated that local and perioperative complications are the primary safety issue with silicone breast implants.
And they occur frequently.
Frequently enough to be a cause for major concern. And these risks, this is crucial, they accumulate over the lifetime of the implant. We're talking reoperations, rupture, severe contracture, infection, hematomas, chronic pain. Device failure is almost a statistical guarantee.
The numbers they cite are just stunning. What about the rupture risk?
In one study, the McGann AR90, the 5-year cumulative risk of rupture was 4%, but that just climbs over time. For capsular contracture, the hardening scar tissue, some studies found rates up to 79% at 15 to 21 years.
79%. So over 2 decades, nearly 4 out of 5 women in some groups had a severe complication. That's not a rare side effect, it's a near certainty.
Which means reoperation isn't a possibility, it's an inevitability. And that's why the IOM made this crucial regulatory statement. They said the nature and high frequency of these local complications must be an essential part of informed consent.
A patient has to know they're signing up for a high probability of more surgery.
They have to. And we should also mention seroma, the fluid that can accumulate around the implant. A late seroma, where the breast suddenly enlarges years later, is especially worrying.
Why is that?
Because that fluid buildup increases the risk of other problems, like infection or more capsule formation. It's another sign of the implant reacting with the body over time.
And the contrast between this documented history of high failure rates and the modern rules, like the European Medical Device Regulation, is just, it's stark.
It's incredibly stark. Implants are high-risk devices, Class I or Class 3, and the MDR imposes extremely rigorous standards.
And it mandates continuous assessment, like the 5-year renewal cycle for approval. Why is that so important?
It forces manufacturers to constantly reprove that their device is safe and effective based on the latest data. It's designed to prevent a 20-year-old device design with a 79% failure rate from just being grandfathered in forever. It mandates long-term accountability.
And the rules about record keeping are also strict.
For implantable devices, they have to keep all the records, design, manufacturing, clinical data for at least 15 years after the last device is put on the market. It reflects the multi-decade lifespan of the risk.
And then there's post-market surveillance, or PMS.
Which is mandatory and stringent. Manufacturers have to constantly collect and review data from the real world. And if there's a serious incident, something leading to death or a serious deterioration of health, they have to report it immediately.
Okay, so let's connect those dots. If the IOM data shows contracture rates near 80% and rupture rates of 4% or more at 5 years, shouldn't that be constantly triggering PMS reports about a serious deterioration of health?
It absolutely should.
Yeah.
The high failure frequency documented by the IOM shows a pattern of performance that is just completely at odds with the high safety bar of the MDR. It suggests that historically, device surveillance was deeply, deeply inadequate.
And let's bring it back to the chemistry for a second. The MDR says devices must be designed to minimize risks from contaminants and residues.
Which clashes directly with what we talked about, the 20 parts per million of toxic residue, the known migration of D4, the release of silicon nanoparticles. The early implants failed that test completely.
So the historical record just doesn't meet the modern regulatory standard?
Not even close. The history confirms that the high frequency of physical failure and the chemical toxicity of the materials always demanded the kind of stringent long-term monitoring that was clearly neglected for decades.
So we've completed a pretty deep exploration here. We've really revealed 2 conflicting narratives, haven't we?
We have. The first is the official epidemiological consensus. Statistically, no reliable link to classic systemic diseases. But this conclusion is heavily qualified by all those methodological shortcomings we talked about. Latency, power, bias.
And the financial conflicts of interest?
And most critically, the extensive and documented financial conflicts that just undermine the independence of the whole thing.
And the second narrative?
The second, undeniable narrative, which comes from the corporate documents and the IOM's own assessment, is one of high physical failure and chemical exposure. Manufacturers knew about migration. They knew about the dangers of silica and D4. The IOM concluded the physical failure rates, rupture, contracture, reoperation, are so high that they are the single biggest safety issue for patients.
So the takeaway for you, the listener, is that the science doesn't prove causation for classic autoimmune diseases, but it overwhelmingly confirms chemical instability, known toxicological signals, and the statistical certainty of device failure.
Exactly. The focus really has to be on the overwhelming risk of physical harm and future surgery. That should be the absolute basis of informed consent.
Which leads us to our final provocative thought for you to consider, based on the framework of modern regulation.
The MDR, the European regulation, mandates that if a device contains a substance that could be considered a medicine if used separately, the regulators have to get a special scientific opinion on its quality and safety. So, considering the known decades-long migration and breakdown of substances like D4, which we know affects animal reproduction, and amorphous silicon nanoparticles, which we know cause cellular damage.
Right.
What level of long-term systemic exposure do we have to tolerate before an implant's components are finally treated as what they are? Adjunct medicinal substances. If these particles are continually acting on the body, doesn't that require the highest possible level of regulatory scrutiny? That remains the crucial open question for regulators and for science.
An essential question, demanding continued vigilance and transparency. Thank you for joining us for this deep dive.